This paper talks about, after oddly proclaiming the obvious value of the mRNA vaccines, what this paper discusses is from what I understand, highly unusual shift in the subclass of antibody that shows up in people who have been vaccinated with the mRNA vaccines after their third dose.
Yeah, so there's my screen should not be on for this, but there's a figure. Yeah, can you take it off so I can just find figure 1 here? Figure 1 is pretty clear, although I'm just going to show part C of figure 1 here. So this is what you're talking about here, the longitudinal analysis of vaccine-induced antibody response with IgG1, in pale blue, IgG2, IgG3, IgG4, the other ones. And what you see is basically after the I don't remember what FU refers to here. There's so many little acronyms in this paper, but basically you have 89% of IgG1 response after the first, or maybe it's the second dose of the mRNA vaccine. And by the time you're at again, I don't remember if it's the fourth or after a booster or two, you're down to 73% IgG1, and whereas IgG4 was almost non-existent, almost untraceable after your first doses, by your second booster, I think it is, you've got almost 20% IgG4 production.
Right. So what I want to do is first just translate this into English and then help you understand why it is that the heterodox people are freaking out about this result. And I don't think the freak out is unwarranted. I think this really is a dramatic and important result that we need to understand. Okay. First thing to understand,
so we can take this off. So you can just talk.
Is that Ig, as in IgG and IgG4, means immunoglobulin, which is a synonym for antibody. So if you've been hearing about antibodies, this is a class. This is really IgG4 is a subclass of antibody. There are major classes of antibodies, which you may have heard discussed during the pandemic. There's IgGA, which is specific to mucosal reactions. One of the critiques people will have heard of these vaccines is that you're vaccinating people in the arm for a respiratory virus, and it turns out that there is a profound impact of where in the body your immunity is, right? So if you're going to get a cut and tetanus is going to get into your blood, right? You want your immunity in the blood where the pathogen is going to show up so that the immune system can shut it down before you get sick, right? If you're going to inhale the thing, right, you want your mucosa to have the antibodies if your response is antibody based. And so anyway, where the response happens, it has something to do with the main classes of antibodies, Igs. And there are subclasses. So IgG is one of the major classes of antibodies involved in shutting down pathogens. And they do this in various ways. I think we've discussed it here before. Antibodies have that familiar Y shape. The tips of the Ys, right? The tips of the Ys have a very unique electromagnetic conformation that sticks to something specific. Right? So you have these things basically floating around waiting for the inverse set of magnets. And when they land on them, something happens. And that something can be that the antibody sticks to the something and just gums it up so it can't do its job, right? Like imagine that there were tanks invading your country and you had a giant silly string gun that just glued up the tank, right? Mm-hmm. And the point is, that tank is not a tank anymore. It can't work. It's too full of gum. So anyway, there are antibodies that just stick to stuff and cause it not to be able to do its thing, right? You can imagine if you gummed up the spike protein on coronavirus, that coronavirus can't use the spike protein to get into the cells. That's the idea, right? But this whole system, the system of immunity, of which antibodies are really half the story. So B cells, which you've all heard of, make antibodies. They have receptors on their surface, but they also make free-floating antibodies, which they secrete. And these antibodies go out and they do things. They gum up stuff. They can also stick stuff together and signal something called a macrophage to come and consume it and destroy it. Anyway, it's a multi it's a multifaceted response to pathogens. But the whole thing depends on an underlying principle called self-non-self recognition. Okay, so the system has to be able to figure out what belongs to you as a result of all the stuff that you do physiologically, and it has to not interfere with that stuff. And then it has to detect all of the stuff that isn't you and figure out what to do about it. Now, in general, the system starts out by recognizing molecules that you yourself don't make that look biological and assuming that they are hostile, right? That causes some problems, though, because you eat stuff that isn't you, right? You inhale stuff that isn't you, and the level of reaction.
Although the eating stuff that isn't you is going through the donut hole that is your intestinal system. So it's technically outside of your body, right? And so that's why leaky gut syndrome and such is such a problem, and celiac disease, where the stuff that's not supposed to be recognizable by your immune system at all gets out of your gut and into your bloodstream, and then suddenly your body can start seeing a bunch of stuff and freaking out about it.
Right. So there's all kinds of stuff about your epithelium keeping the stuff that's not supposed to be exposed to your immune system outside of you, whether outside of you as in your alimentary canal or physically outside all of you. But anyway, so the system is extremely elegant. And the thing is, it's far more elegant than we yet understand. We are still at a very crude level of understanding how this works. But we do know that in utero, the system basically fires, right? Imagine you as a mammal inside your mother's uterus. You're not exposed to a lot of stuff from the outside. So the system can say, all right, which of our antibody-producing cells are being triggered by stuff that we're seeing? Those aren't good. They react to self. Get rid of them, right? So now, by leaving only cells that didn't react to you, you've got a non-self recognition system. Beautiful, until you get into the world and things get complex, right? Now, here's the amazing thing. Now, I remember I guess I would have been a college student, I had seasonal allergies. And I went to the allergist, and the allergist did a panel and figured out what I was allergic to, and then cooked up some inoculations. And I asked, because I'm biologically oriented, I'm like, what's in those? And he's like, oh, the stuff you're allergic to. It's like, well, that doesn't sound like a very good idea. Why are you inoculating me with the stuff that I'm allergic to? That sounds like
I'm also clearly already exposed to it. It's what's causing the problem that sent me in here.
Exactly. Right? And so I asked, I don't understand why does this work? I'm not saying it doesn't, but why does it work? And he went through a very complicated explanation that meant nothing. In other words, they didn't really know. Okay.
Did he think they knew?
I think he kind of thought they knew in the way that doctors sometimes think they know, but they're out of their depth. And I'm not arguing that is in and of itself. Sure. Thinking you know is bad, but doing something that works, even though you don't know why it works, that's not inherently wrong. And that's how medicine functioned, right? You understand stuff a lot before you understand exactly why it functions the way it does. But anyway, I was alarmed at how little seemed to be understood by, somebody directly in the field. Well, it turns out,
you did not take the inoculations?
I did, and then I stopped. And actually, my allergies went away years later, I think because I changed all sorts of other stuff that had to do with a general inflammation problem that was causing me to be exposed to many more antigens than I should have been. But to make a long story short, self-non-self recognition is established in utero, but then it is maintained by a very elaborate system that modulates immunity. Now, here's the punchline of that story. IgG4 is a subclass of antibodies involved. I'm not saying this is all it's involved in, but it is involved in the downregulation of immunity, right? So imagine that you face some molecule out in the world and you're overreacting to it, right? That's bad, right? That causes all kinds of problems. And one thing that the body can do is it can update its understanding of what is hostile and what isn't hostile, and it can cause you to not react to something, right? It's like, look, by analogy, you have a panic response. Your panic response is presumably there because a certain number of ancestors have survived something frightening and then left offspring as a result of the fact that they panicked appropriately, right? There are all kinds of situations in which you don't want to panic, right?
Most of them.
most of them is right.
The vast majority,
especially in modern times. But, if you're in water, panic is not good, right? Learning not to panic in water, right? Like you and I grew up on a coast, right? As you're dragged out to sea by the riptide, panic is not your friend, right? If you fight that riptide, you will exhaust yourself and you may well drown. If you realize that riptides are short entities and you let it take you out, which is frightening as hell, and then you swim horizontally, you will escape that riptide and then you can swim in, right? Not panicking is the key to surviving. So riptides tend to cause panic as you notice it's happening. Learning not to panic is the key to survival. IgG4 is like this, right? To the extent that something you're encountering is a bummer because of your reaction to it, not reacting to it is key. And so it is not terribly surprising that the system has a mechanism for downregulating a immune response.
So I don't want to jump ahead here.
Yep.
But as I understand the paper, I've never made a claim to be an immunologist, and I don't know as much immunology as you do. They have found that the greater the exposure to the mRNA vaccines, the higher the ratio of IgG4 among a total of all of the IgG cohort that your body is producing is, which, given the piece of information you just added to the discussion, means that your immune system is being tamped down, potentially, the more boosters you get. They also find that those who have been vaccinated and then get exposed to COVID also are producing more IgG4. And they went and looked at a couple of other vaccines. I think it was typhoid, maybe. You don't need to show my screen here yet, but no, not typhoid, tetanus and RSV. They say the IgG4 subclass does not prevail after repeated vaccination with tetanus toxoid or respiratory syncytial virus infection. These findings support the notion that class switching to IgG4 is not a general consequence of repeated antigen exposure in form of vaccinations or infections.
Yep.
So this is and it's specific to the mRNA COVID vaccines.
Yep.
And not generalizable, at least to two other vaccines, one other vaccine and one other infection that are active in the human population now.
Right.
Yeah.
Now, I don't want to pretend anybody really understands what this all implies, but it does open some very scary possibilities.
Yes.
So one thing is that the repeated vaccination, and you and I and others have warned about what we don't know about continuing to send the same alert signal into the immune system in a dynamic, complex system, right? So these vaccines were insane in a number of ways. One of them is they're too freaking narrow, right? You are like a child playing against a tennis pro, right? You are delivering an evolutionary challenge that is not difficult for this virus to overcome. Mm-hmm. And you are doing so repeatedly, right? You keep playing the same move in tic-tac-toe and not learning that it doesn't work, right? So, okay, we've talked about things like original antigenic sin, right? Original antigenic sin means that if you overly train your immune system to have a particular reaction, it doesn't get to experiment and find a better reaction, right? So that's one hazard here. Antibody-dependent enhancement, right? You're talking about an evolved entity that is trying to get into your cells to do its own bidding, right? It has encountered antibodies before. It happens all the time. And so the question is it built in such a way that it can actually utilize those antibodies in a jujitsu-like way to get into a cell that it couldn't otherwise invade, right? Mm-hmm. Of course, that has been experimented with by selection. And so that is always a danger when you're inducing an immunity. So how do we know that's not going to happen here? Well, this adds a whole new category, right? Yeah. To the extent that your body, and my guess is if we study long enough, we will find that there are pathogens that have figured out this trick. Maybe even COVID has figured out this trick from before. But the idea that there is a system for attenuating immunity and that it is being elevated at a spectacular level. I mean, from
non-existent to 20% of the IgG response.
Yeah, from something like 0.04%.
It might have been 0.4, but they gave a number, but then they also said almost not measurable.
Right. It's almost not measurable,
Yeah.
which you would expect.
At the beginning.
To the extent that you're fending off something, the attenuation antibody is not the one that you want to be producing. It's counterproductive, right? It's its own goal, right? So the fact that this thing is being elevated tells us, A, if they've only surveyed a couple of previous vaccines, but they've said, hey, look, here we've got some vaccines we know actually work, and it's not triggering this. B, if you've been vaccinated and then you get COVID, it is being triggered. That's interesting.
That is interesting. This is also interesting from the discussion of the paper. Furthermore, we observed significantly higher IgG4 levels after 2 doses of Comirnaty, which I also never know how to pronounce, the Pfizer vaccine.
I thought it was Comirnaty, but...
Comirnaty? Okay, I'll start over. I'll go with Comirnaty. Furthermore, they write in this Science Immunology paper released December 22nd of this year, furthermore, we observed significantly higher IgG4 levels after 2 doses of Comirnaty mRNA vaccine compared to a heterologous immunization regimen with a primary Vaxzevria vaccination followed by 1 dose of Comirnaty, although the total anti-spike IgG response was comparable. This argues against the hypothesis that repeated exposure to the spike protein itself triggers the unusual IgG4 response. So, it's a small study, and there's a lot here that is beyond my ability to assess directly in terms of their methods and the tools that they're using. But they seem to have covered a lot of bases in terms of like, oh my God, does this happen whenever you get repeatedly exposed to a pathogen? Nope, not with RSV. How about whenever you get repeatedly exposed to a vaccine? Well, no, not with, again, what was it? Tetanus, I think.
Yep.
Not with tetanus. Okay, how about if you just get vaccinated a lot against COVID, but it's different COVID vaccines? Nope, not that either. It's the mRNA COVID vaccines repeatedly being vaccinated against, getting repeated exposure to that. And they don't say Moderna here, but my guess would be that either Pfizer or Moderna would do. You could mix those two, and you would get the same response. But I don't know. They don't appear to say it.
I think that's implied by the paper.
Yeah.
So that argues that this isn't a strict case of original antigenic sin,
right?
Because it's not the antigen that's doing it; it's something more complex. And it could be, it could be a lot of things, right? This is such an alarming, strange result. I'm not saying that this is right or that I even believe it. I'm just saying one hypothesis is that the destruction to the immune system that comes from the pseudouridine enriched mRNAs being consumed by macrophages. Do we know that destruction happens? I don't think we know that yet, but it's certainly likely that macrophages, which are capable of digesting normal stuff, might choke on pseudouridine enriched mRNAs that are spilled out when a T cell destroys a pseudo-infected, transfected mRNA spike-producing cell, right? That could be resulting in a shift in immunity as a result of some kind of exhaustion. Now,
immune exhaustion?
Yeah. Let's put it this way. My model doesn't tell me how you get from macrophages ingesting this stuff to that kind of exhaustion, but who knows? We now have a question on the table, which is why are we seeing this radical shift in the direction of standing down an immune response where you would expect it to be elevated?
Yes.
Right? So that's troubling. What's also troubling is because this is mediated by an antibody, it is mediated based on a particular electromagnetic signature on the surface of whatever it is that these IgG4s are targeted at, presumably spike protein. So what that means is that if you imagine your immune system can react to just about anything, large biological molecules. That way it can recognize any invader, whether your ancestors ever saw it before or not, right? And then if you reacted to everything, you'd react to yourself. You'd tear yourself apart before you were ever born. So you get rid of all of the stuff that looks like you, right? That digs a big hole in your immune system, right? All the stuff you yourself make is placed off limits from immune attack. Autoimmunity is the result of of that border not being well policed. And there are various reasons that might happen. Mm-hmm. And a pathogen might learn to look like you enough that the immune system would either let it go free or pursue it into that hole and start attacking you also, right? So something like rheumatoid arthritis, right? Yeah. Where you're attacking your own tissues might be the result of, that damned if you do, damned if you don't immune predicament. But the point is, look, okay, we've specified a sequence. And now the immune system has reacted in the way that we've done this by apparently standing down an immune response. Now we're creating an opportunity for the pathogen, right? And not just this pathogen. We're creating an opportunity for any pathogen that can evolutionarily produce a signal that triggers that same reaction, mm-hmm. right? So
not exactly the moment. At this moment, in the global north, when many illnesses are cropping up because people are inside and it's dry and respiratory viruses just have an easier time transmitting for both of those reasons. Sure enough, we have what is shocking to all of the health professionals and public health authorities is a sharp rise in very bad cases of both flu and RSV. And your point is, given, if this paper holds, if the result in this paper published a week and a half ago in Science Immunology holds, and it turns out that the more exposed you have been to the mRNA vaccines against COVID, the more likely you are to be basically having your own immune system tamped down by your immune system itself. You may well be more susceptible to not just COVID, but to all the other stuff out there.
Yes, you are at least, and worst of all, because we jumped in with both feet and vaccinated, billions.
Everyone who was willing.
Billions of people worldwide.
And many who weren't.
I don't know what fraction of that billions got an mRNA vaccine, but let's say it's 1 billion people.
A majority, yeah. I think. Well, actually, I don't know.
Well,
Russia and China.
China used a very different
I don't know.
thing. So I don't know what the answer is, but let's say it's 1 billion people. Nothing is dependent on the exact number. Okay. What we've created is a gain-of-function experiment for the other viruses that we weren't tampering with to see whether they can figure out this formula for escaping immunity. Right. So, look, you and I used to say all the time, I don't know why we stopped saying it because it's been the message all along, but we used to say all the time, welcome to complex systems.
That's right.
Welcome to complex systems is our shorthand for you are dealing with a system you don't know nearly enough about to make any sort of a radical change and think you know what's going to happen, right? To the extent that you are deploying a new vaccine, you don't know, even if it's a traditional platform vaccine. We've seen this go wrong before where people have released a vaccine that was made in a traditional way and it had unforeseen impacts. The idea that you could get away with speeding up the development of some radically new platform of vaccine and assume that it was going to be without major harms or impacts was never made any sense. And here what we're seeing, I think potentially we're seeing a couple of different contributing factors. We've got the immune system is a complex system. Inside a person, a complex system. Inside a society, a complex system. Inside a pandemic, a complex system, right? That is a nightmare from the point of view of predicting net impact. Yep. We are now looking at a population level change that may have severe implications, not just for this pathogen, but for others. So that's one lesson, is this is human biological hubris coming back to us in the details are shocking. The fact of us having been this wrong cannot be shocking. That was foreseeable. But the other thing is...
Us being the public health apparatus.
Yeah. Humanity, what we net did was insane. The other thing is you and I used to take a lot of crap from various people over the question of lab leak and whether or not it, quote unquote, matters, right? There was a whole midwit kind of conclusion that, well,
there's a lot of that going around.
so much. Yeah, the midwits have definitely had their day. But their perspective was...
normal distribution of wittery.
Yeah, right. Their perspective was, look, wherever it came from, it's here. Mm-hmm. Let's deal with it. And the answer, what we have said from the beginning is no. What you did to this virus has implications for everything. It has implications for what we should expect it to do, mm-hmm. for what we should expect it to be capable of. It has implications...
how it will respond to various treatments.
How dangerous it is, and how good your model is of predicting that. Mm-hmm. So here's another place, right? We've been dismissed as...
will it evolve into lower virulence over time, as all the other viruses tend to do? Not all of them, but most of them. Well, maybe. Right. But this is the first of its kind.
This is the first of its kind. And... also, how much you can infer about how dangerous it is from the case fatality rate, right? Our point has been, look, this disease, as much as it's not all that deadly, mm-hmm. is very destructive, right? It is very destructive across a wide range of organs, which likely has something to do with the protocols that its ancestor was exposed to in Wuhan, right?
Yes.
Where, for example, caged animals did not have to function in order to pass it on, right? A mink in the wild that gets sick with the virus has to function as a mink in order to pass on whatever disease it has. So the disease has an interest in not making the mink dysfunctional. If you've caged a bunch of ferrets together so that they're slobbering all over each other, losing their ability to smell and therefore feed themselves, but it doesn't matter because they're eating ferret chow, mm-hmm. right? The point is you have created an environment in which a pathogen does not need to worry about damaging tissues that don't help it because it doesn't matter, right? So did that...
it's the evolution of sloppiness.
It is an environment that is highly tolerant of sloppiness. Mm-hmm. And so what we are now looking at, look.
Yeah, this is not a precision pathogen.
Right.
It seems very precision, like a spike protein. It's, we got to target this thing, and that's the thing that may be really, causing a lot of cellular damage. But it causes such widespread damage in so many different systems and ways. And yes, the CFR, the case fatality rate, is probably not, we were saying from the beginning, is probably not, and I would say now definitely not the indicator to be using to assess whether or not this is a dangerous virus. Look at excess mortality over time. Here we go. Yes. It's not looking good.
Yes, and actually one of the, I was reading a blog post, not on Substack. Very surprising to see any blog post not on Substack these days. But you want
me to show it?
Yeah, you want to show it? Radagast? Yeah. Anyway, this is...
what you just said.
Radagast is the guy who wrote it, who actually strikes me as a very interesting author. He did a good analysis.
I don't know it, and I can't see it yet.
Yeah, but anyway, it'll pop up here. Why was I raising him?
I don't know. You have blog posts, not on Substack. Written trial. The only way to deal with an unfree world is to become so absolutely free that your very existence is an act of rebellion. Cool. Why were you bringing this up? I do not know. This is the first time I've seen it.
I can't remember exactly. It seems to me that I think it's a he. His analysis is excellent with respect to the complex systems point, right? He does not overly interpret what we have just learned, but he sort of speculates responsibly about it. It's a very good post. I would also recommend.
You want me to show the other one?
Yeah, Jessica.
Hold on just a second. After mRNA vaccination, the immune response against spike is shifting to IgG4. So that's just a summary of the Science Immunology paper we were just talking about.
Yeah.
Okay.
Yeah. I can't remember exactly. It'll come back to me, I'm sure, but
I'm sure it will.
But I don't have it. But I would also recommend Jessica Rose has done a number of pieces. She has actually been quite good on the question of attenuation, but also on the question of pathologies that may be arising from this. I would advise real caution here, because the fact that IgG4 is known to be associated with something like the development of cancer doesn't really tell you what role it's playing, and therefore we can't leap to conclusions about the connection between certain things.
Can I just say before you go on, I've not seen this post before, but I'm looking at it, and for those just listening, she starts the very beginning of the article, which she titles IgG4 related disease means fibrosis and organ destruction that leads to death eventually. The article begins, let's get some definitions out of the way. She defines fibrosis, connective tissue, collagen, type 1 collagen, and presumably more. And just that, starting with that right up front so that the reader can, if they don't already own those terms in their head and they can read them without having to refer back, they know exactly where to find them. And compare that to the Science Immunology paper, which I think was well done. But I ended up highlighting all of these acronyms through it just as a way, like the first time they would use them, I can't keep track of all of this. Yeah. And so, this is not necessary. This is not new. But even the way that Rose has written her piece there, which I haven't read, I immediately know that she is at least attempting to be a clear communicator such that people can come to their own conclusions. Yep. And that is that's not standard scientific communication style, in part because it takes more words and paper used to be at a premium and journals used to be printed on paper. Like that's the sort of explanation for why you have this really tight sort of telepathic scientific writing style. But there's not much excuse for that now. And even just having a little sidebar glossary for all the terms on a paper like this would help a lot. And that does, it creates a barrier to entry for almost everyone, the way that Rose article looks like it shouldn't have, really. Like I don't think her article has that barrier to entry. She's inviting everyone in to read and to assess. And frankly, this is part of what those who would erect the barriers to entry really don't want us doing. Like they don't like what we're doing. They presumably don't like what she's doing. They don't like what a lot of these doctors and researchers are doing, saying, you know what, I actually did train in something like this or related to this, and I can assess these things. And so I'm going to communicate to all y'alls who don't necessarily, want to read Science Immunology, but we can assess it and say something about what it actually says. And for many, that is basically a breach of a contract between elite and not elite, between educated and not educated. It brings power and agency back to people where it belongs.
So the distinction I've drawn is between what I would call terms of art, which are a necessary evil.
Yes.
These are terms that we have to have in order to communicate about things. So IgG4, for example, you need a term to refer to this special subclass of antibodies in order to have that discussion. But it's better if you don't have it. Whereas jargon, which is the alternative, is the barriers to entry that are placed by so-called experts to keep people from understanding what they're saying so that only the experts can discuss it and they don't get exposed for what they don't know. Right. So anyway, Jessica Rose does a great job of bringing you in by just saying, look, here are the things you're going to need to know to understand what I'm talking about here. Mm-hmm. So we do have a tremendous issue with nested complex systems that have been interfered with in a radically novel way that is now having a consequence we can measure that nobody fully understands, but may be connected to any one of a number of pathologies that have been seen. Could be connected to rapid cancers, could be connected to fibrous clot-like developments, as Jessica Rose argues. But the real answer is stay tuned. Yeah. We will find out more about what this means over time. There will no doubt be an insane propaganda campaign designed to demonize those who become interested in this because, frankly, it is at the very least a tremendous challenge to those who are arguing that there is a role for these so-called vaccines going forward.
At least two things here: mRNA vaccines and therapeutic treatment in general, and gain-of-function research.
Right. Yeah. We have opened Pandora's box and run out the clock on all of our good options and deployed technologies that have made things far worse. And at some point, we should stop using whatever mechanism it is that's telling us what to do next, because we are doing ourselves more harm, right? And what I would like to know is what we have done collectively that has been of any value whatsoever, right? We caused the problem, apparently. We then exacerbated the problem.
Sure.
At some point, not listening to the people who set any of those plans in motion would be like a first step to doing something reasonable, I would think.
It sounds like misinformation to me, Brett.
That's what they call me.
Misinformation?
Yes. I was voted that
Did you
in high
win?
school. I did.
Okay.